Hello, welcome everyone. Thank you so much for being here. You are here for the webinar, Setting the Stage, Distinguishing Science from Falsehoods. I'm Heather. I am the coordinator for the Forest Carbon Coalition, and my co-moderators today are MC and Jen from the John Muir Project. The way today will work, we've got 3 panelists. Each of them will give a presentation. We will save questions till the end. So there is a Q&A box down at the bottom of your screen. That's where you can submit your questions. The chat is turned off. So any questions or comments that you have, please put in the Q&A. This is being recorded and will be sent out to all registrants. And some other housekeeping. If you have any technical difficulties or or can't hear or something happens, please drop that in the Q&A as well. We've got Doctors Bev Law, Chad Hanson, and Monica Bond with us today. So thank you so much for being here. You'll hear from Bev first. She's going to be talking to you about carbon, and then we'll hear about wildfire from Chad, and then we will wrap up with information and the science behind biodiversity with Monica, and then we will open it up to the Q&A. So the Q&A is not live, but we will go through as many questions as we can and answer as we go. Any questions that we don't get to, we will follow up afterwards. When I send out the recording, we'll get as many answers to questions as we can. All right, we are going to get started. All right. Sorry, I am trying to share my screen. There we go. All right. Hope everyone can see that. All right. Dr. Law.
I'll go for it. So I'm a professor emeritus of global change biology and terrestrial system sciences at Oregon State University. And I've been working on the effects of wildfire management and climate on forests and forest carbon and water for the past 30 or more years, and doing carbon budgets. So I'll get going right here. Next slide.
Right. Sorry, it's not
responding.
Not responding.
I'll start talking without responding because I know what's on the next. Oh, there we go. Yeah. So, I think it's really important that we think about what are international commitments. And there's global scientific consensus about what I'm going to talk about on carbon and climate change and biodiversity. And here are the agreements that are most pressing and most recent: the IPCC, Intergovernmental Panel on Climate Change. 2022, the Science for Policymakers report, SPM, has a lot of these statements in here, and they're much more dire than they have been in the past. And now it says that the next 10 to 30 years is a critical window for climate change action. And that's when we expected severe ecological disruption to occur. Well, it's already occurring, as everybody is seeing. And a new statement came out from the World Meteorological Organization that says if we do have an El Nino within the next 5 years, will likely exceed the limit of 1.5 degrees Celsius. And that's scary because that's the mark that we're trying to stay under. Other statements that were in here that were not in previous reports is safeguarding biodiversity and ecosystems is fundamental to climate resilient development and the light of the threats that climate change poses to them and the role in adaptation and mitigation. Then maintaining resilient biodiversity and ecosystem services depends on the effectiveness of equitable conservation of 30 to 50% of the Earth's land, freshwater, and ocean areas, including current natural, near natural ecosystems. Before they only considered managed systems, what they called managed. Well, that is why we have not succeeded in getting our emissions down. And then the last one is climate change and biodiversity must be considered together because you don't want to have actions taken to address one of them affecting the other. Next. Yes, it's my eyes blurring. Okay, and this is a global assessment that happens every year, and so the results here are recent. It was the most recent year that they did the analysis of, but they're showing what the sources and sinks are. The sources, of course, fossil fuel burning and so forth, and then deforestation is 11% of the sources, and they have to balance. So the sinks, 29% is being taken up by the terrestrial ecosystems, most of which is forest that's doing the job, and then 26% by the oceans. The remainder is in the atmosphere. So the amount that we put in the atmosphere, only half of it has remained. So thus far, these systems have been keeping us alive and everything healthy. When it comes to carbon stocks, forests account for 92% of all the terrestrial biomass globally. And then 30% emissions, or 30% of the emitted carbon that ends up in the terrestrial ecosystems, and it's been doing that, staying right pretty stable around 30% for the past 60 years. That may change. So, and another IPCC statement is not only do we have to quickly reduce greenhouse gas emissions, the natural sinks must remove considerably more and store considerably more atmospheric carbon dioxide and do this. Really, we have to start now. We can't wait 10 or 30 years. We have to start now. Next. So what we found from numerous studies now is accumulation of stocks in mature and old forests is the most effective forest-related climate mitigation strategy. And mature and old forests have the highest carbon densities. They retain more of the carbon on site, live or dead, and they retain it in the soils. There's a lot of nonsense out there about young forests being better. It's better to cut the mature and old forests and grow young forests because they grow faster. That's not true. They haven't done the numbers on this. We have, we and many other people. So they also serve as carbon banks for decades to centuries. We have trees that live to 800 years old. You can see in the graph 600, we just cut it off there and said 600 or more. And the graph, the open symbols are the federal lands. And you can see the the private lands, the black dots are the younger forests, mostly younger forests. So it's important to not harvest large trees and old forests, mature and old forests. Next. Another study we've done is about the 21-inch rule that was very successful. There was a Northwest Forest Plan, and the 21-inch rule was the eastern part of Oregon comparable activity that went on, and it started about the same time, around 1990, 1992. But in this case, they had a rule that trees larger than 21 inches diameter could not be cut. Well, now it's been laxened because they want to cut some of the large trees and some of the oldest trees. Well, those trees that are larger than 21 inches represent only about 4% of the trees, but they account for 46% of the carbon stocks. So I turned this around and said, well, what if you took the rule and you changed it to where you protect trees that are greater than 15 inches in diameter? Well, that would protect 70% of the carbon in trees. So it shows you how you can use observations. These are 600,000 individual trees in 6 national forests. And as the graph on the right there shows, that blue line shows, well, what if you did this? You change it to 15 inches. Well, you could really increase the amount that is protected. So if rules are put in place, they I don't like the idea of saying we're just going to pick an age and use this age everywhere. I don't think that's right. But there, you can see how much more you can do by simply modifying the level at which you say you're not going to cut those trees. This is like for federal lands. So next slide. Once forests are harvested, carbon is released to the atmosphere. This graph here shows it, and this was in a paper that we just wrote where we have all these factoids that explain why some of the strategies that are out there won't work. And it's that 2022 when it's in land. Converting mature and old forest to young forest results in significant loss of total carbon stores, even when you consider the wood products. So what you're hearing out there is, let's cut to the mature and old forest and then plant young forests and they grow fast. And then we'll put it into wood products and it'll be stored there forever. And they say infinity, or they say, how many ever years. But this graph shows, and it's using observations, that the green line is an unharvested forest. The yellow line is a harvested forest plus the carbon that's stored in the products. So you can see the gap between them. And it's even after 120 years, an unharvested forest stores more carbon than a harvested forest plus its products. So that's astounding. You're hearing all of this nonsense that saying we can do more and it's stored for, it's just not the case. When you run it through a very good life cycle assessment that accounts for all the harvested wood and what it goes into, how long it lasts, it's cradle to grave, forest to landfill, and including landfill decomposition. So this is a really important thing that must be done in a lot of places, and people need to learn this. This has been the thing that we've been dealing with our whole careers, is the misinformation on this. Next slide. Another analysis we did with our life cycle assessment was for the West Coast states, Oregon, California, Washington, for the years 2001 to 2016, using inventory data again and modeling. We found that fire emissions were low relative to harvest-related emissions in all three states. It averaged, the harvest-related emissions averaged over the three states 5 times fire emissions, even during this period where we had multiple fires come through, multiple fire years, 2002, 3, 15, 16. So you're not hearing that. That's another thing that's been twisted around. And then only 19% of the wood harvested in all three states since 1900 is currently stored in wood. 65% of it is in the atmosphere. So again, it's not the products that are going to store it forever. It's better to keep it in the forest. So harvest, and then I guess the main point of all this part with the fire, comparing fire and harvest related emissions, is harvesting more to reduce fire emissions makes emissions worse. Next. On to natural climate solutions. These are approaches, and everybody's looked at strategies for different land use strategies like reforestation, avoiding forest conversion to other land uses, and natural forest management, and which can be claimed in different ways. And that in that figure on the right is one of many global studies that have been conducted. And it uses as much information as they can with remote sensing to come up with these estimates. And their estimate for reforestation was quite high. And regardless of the numbers, the global studies showed that natural forest ecosystems can contribute to the solutions and not the problems. So when you can quibble about the reforestation part of it, but even if you reduced it, a following study lined up all of these other studies that have looked at this on a global scale or a national scale. And they compared it to how much more do they have to take up from the atmosphere over this time frame. This one is well within that amount, even if you had much less that's actually able to be reforested. And so it does show that it can contribute, even though this other study had something like 50 papers that they evaluated, and it was really pretty important analysis. And so, and one of the justifications, or two of the justifications for this, is mature and old forests are working now in spite of the climate effects that we've had. And there's no startup time. So we've got that 10 to 30 year window of making substantial progress. And then the cost is minimal compared to technological solutions that are not to scale. And the technological solutions I'm talking about are carbon capture and storage, or CCS. There's been so much emphasis on it. There's been a lot of money poured in it, billions put into it, and so far it's failed over the past 10, 15 years. And now the amount, I think it's 400 billion has been put into this carbon capture and storage. It's not to say it's either or, both should be done, but don't rely on this to get there soon enough. So that's an important point there, because there are people that are just saying, oh, we're safe, we can keep polluting or whatever. They'll just be capturing it. That's wrong. That's terrible thinking. There's, you know, that's in so many ways. All right, we'll go on. Next slide. So you have global and national studies, and we need more studies like this Oregon feasibility one. We have so much data in Oregon that it made it quite easy for us to test these. And we were looking at feasible actions that could be taken. We're trying to get it as close to reality as we could. And we found that the most effective climate mitigation strategy was to restrict harvest by half on public lands and double the harvest cycles on private lands from 40 years to 80 years, which is where it was 30 years ago when I moved to Oregon. So it's not that that's astounding, that's where it used to be. Those were the most effective. Reforestation, we only reforested within the boundaries of current forests. And then afforestation, we only used lands that were forest, and now are about over 50 years ago, that's what qualifies technically as afforestation, that it was forest. 80% of our forests in the valley, Willamette Valley, have disappeared. But if you were to afforest only non-food grass crops, that's how much you would get. So combined, all of those would double the forest carbon by 2050. So, and then also we looked at an offsets program like California's, its compliance. The companies cannot offset more than 8% of their emissions, and that's to hold them accountable for reducing their emissions further. And so we showed we have plenty of land to be able to do this here, right in the state. So, you know, what came from the other paper that was comparing the national and international natural climate solutions, they had come to the conclusion that conservative estimates of reforestation and afforestation based on refilling past carbon losses are likely to be more feasible and have more co-benefits. And that's co-benefits to water and biodiversity. Next slide. So another study we did further, this is like stepping stones of activities that we said, well, okay, now where would you put this? Where would you put these areas, and how would you prioritize where you protect forests? And we looked at biodiversity and or carbon, and then water security. In this case, it was drinking water sources. It's a database full of that. So we found that in general, permanent protection at the highest levels, which is gap 1 and gap 2, allows existing forests to continue to store and accumulate vast amounts of carbon. And gap 1 and 2 means you cannot do logging extraction. Gap 2, this is USGS classification of protection for biodiversity, and it's useful for this too. So gap 2 allows some degradation after wildfires if there has to be some work done to remove wood, but not typical logging that's going on federal lands right now. Next slide. And this is it mapped out. So first question that comes to people's minds, well, you're going to protect all this area, but what about the losses to fire and to drought? On the right side there, we did a run through where we removed lands that are likely to experience mortality from drought or fire under future climate conditions. So we ran an Earth system model with observations. And the yellow there are the areas that fall out as being highly vulnerable to mortality. And so we ran it with allowing those lands to be preserved. And the reason for that is animals and plants still need a place to live and go. So regardless of those risks, we still might need to be able to protect as much as we can, this 30% by 2030 and 50% by 2050. So we found that 65% of the high priority areas are on federal forest lands, and that's better for ensuring permanence than on private lands. And then it would triple preservation of the drinking water supplies, the sources, the forest carbon, and the species and habitat by 2050. Well, that's fantastic, but it also shows how little we already have protected. So there's a lot to be done. The nice thing about this kind of analysis, and it should be done at the national level in fine resolution, is to identify those areas that are priorities for protection first, because now there are all these carbon projects that are coming up. And the latest one is this climate smart commodity projects that the USDA just released, and they're putting money into these projects, and it's willy-nilly. It's not organized in thinking about, yeah, but are these high priority areas for protection? And if these are, then they shouldn't be doing commodity studies in them. So I think the feds have to get their act together. The tail is wagging the dog. We need to be thinking of this through this very strategically and starting at the top like this. Next slide. So there are opportunities for win-win in natural climate solutions. They're listed there, the ones I've talked about. I didn't get to indigenous and rural communities, but there's some costs. It requires land and it requires permanence. Again, some of the current carbon offset markets that are out there, the projects that are there isn't, we're reading about permanence, that they only are committed, some of the projects, to 1 year, a couple of years. We mean permanence, we mean permanence. And so it's really important for this to be evaluated before the projects are even approved. So, again, it's getting the cart before the horse. We have to know where these places are that are most important to protect. We have to know, will these projects succeed at what they are supposed to be doing? Are they really reducing the emissions, forest-related emissions, and then therefore reducing overall carbon dioxide emissions? So last slide, I think I summarized it there. Well,
that looks like the last slide.
Okay, I'll just so I'll just say that again, is that permanent protections at the highest levels. So gap 1 and gap 2, not gap 2.5 or 3. And some of these areas that are in gap 2, 3, 4 could be moved up to gap 2 by changing their ways, changing what they're doing on the lands. But anyway, we need that permanent protection to get us to 30 by 30 and 50 by 50. It's not just 30 by 30. There is a new study out that is confirming this even further, as if we needed another study to show that we need to give half of it, the land, back to the forests and the animals. And we need to have carbon accounting by independent group, the federal oversight in terms of making sure that the projects are meeting the expectations, and they need to have their expectations down because we're all counting on making the reductions. It's called nationally determined contributions as part of our the international agreement. We have to know if we're succeeding at this. And so far, we showed at the last COP, we've gotten nowhere. In fact, it's worse. So these are some of the holes. These are some of the ways to try and fix that. And I'll stop there.
Thank you. Thank you so much, Dr. Law. Again, Dr. Bev Law, she's Professor Emeritus of Global Change Biology and Terrestrial Systems Science at Oregon State University. So thank you so much for your time. We are now going to hear from Dr. Chad Hanson, and He is going to be speaking about fuel reductions or logging and whether it protects communities from fire. Chad is the co-founder of the John Muir Project and is a leading expert on forest and fire ecology. So I will share my screen and then turn it over to Chad.
Thank you very much. I'll just give a little brief intro.
Chad, I believe you are cutting out. Chad, maybe turn off your video. Yeah,
I'll turn off my video. Hopefully that will help with bandwidth. So yeah, I'm going to be talking about one of the key arguments that the United States Forest Service and the logging industry are using to perpetuate current logging policies that are making climate change worse. As Dr. Law covered so well, the argument that's being used is, well, we can't really worry about that because we need to do all these logging projects out in the forest, supposedly to save communities from wildfire. So that's really what I'm going to focus on today. Next slide, please.
Oh, why is it not? I'm having difficulties with being able to move. Oh, there we go.
There we go.
Okay, sorry.
That's all right. So I have a lot more information on this in my book that I came out with last year called Smokescreen: Debunking Wildfire Myths to Save Our Forests and Our Climate. I wrote it for a lay audience, for non-scientists, but I have hundreds of studies. Lots of information in Smokescreen. Next slide. All right. So one of the key things that comes up is this notion that denser forests will burn more intensely when fires occur. That somehow if a forest is denser, that it's going to burn more intensely. I think that the figure got messed up there somehow. It's supposed to be horizontal, but bottom line is that as forests get denser, you actually have typically less potential for more intense fire. And it's just because of the microclimate of a denser forest. You have more cooling shade of the forest canopy and lower wind speeds. Next slide. And interestingly, forests that have not burned in a very long time, which tend to be denser, they do not tend to burn more severely when fires occur. There's been lots of research on this. I've published studies, lots of others have published studies on this as well. And you can see those black lines there on the bottom, that's high severity fire. TSF is time since fire. And so what you can see is the forests that haven't burned in over 75 years, they actually have less high severity fire than the other forests. We researched this here in Nevada and we found it was about the same. There wasn't a difference. But bottom line is the notion that denser forests will burn more severely. In other words, forests are more carbon rich. The notion that they'll burn more severely is contradicted by the evidence. Next slide. Now, forest fires are driven mostly by weather and climate factors, hot, dry, windy conditions, especially in a drought year. That's what drives fires mostly. You can't fight the wind with a chainsaw. And we found in one of the largest scientific analyses ever done on this question, Bradley et al. 2016, which we published in Ecosphere, we found that forests with the fewest environmental protections and the most tree removal tend to burn the most intensely. Those fires are often burning toward towns. Next slide. Logging is not preventing fires from reaching towns. In fact, they're oftentimes reaching towns faster. And this is just one more study. There are many, many studies that have found this, but fires often burn more intensely and then spread more rapidly in areas where commercial thinning has occurred. And this is a paper that looked at different modeling scenarios, and in the majority of them, fire intensity went up in the commercially thin forests. Next slide. Now, this is something, again, that goes to the microclimate question. And when you remove the forest canopy or a significant portion of the forest canopy, you remove the windbreak effect a denser stand of forest has. You remove a lot of the cooling shade of that forest canopy. You create hotter, drier, windier conditions. And this is a quote from a study from Stevens et al., 2021. These are folks who are very much proponents, supporters of commercial thinning, but they acknowledge that their research shows that it makes fires spread faster, get bigger faster. And again, when they're spreading faster, they're reaching towns faster and people have less time to evacuate. And this is, again, from these folks, Stevens et al., they're saying it's a combination of higher mid-flame wind speeds and a greater proportion of grass fuels that are growing in because of the extra sunlight due to reduced canopy cover from logging. Next slide.
Chad, I think we have lost you. We can no longer hear you.
Sorry about that. It looks like I lost my bandwidth for a minute. I switched over to something else, so hopefully it's fixed. Can everyone hear me okay? Thumbs up if you can.
Yes, we can hear you now.
Perfect. Thank you. All right. So was the audio okay in the last couple of slides, or should I go back one or two?
You went out on this slide that's up right now, the creek fire.
Okay, that's fine. So we've looked at this in a lot of the recent big fires. This is a study that I did last year on the creek fire, which was a 380,000 acre fire in the southern Sierra Nevada in 2020. And I looked at soil severity and how the fire functioned in areas where different types of so-called fuel reduction logging had occurred, mostly commercial thinning and post-fire logging. And what I found was that the areas with so-called fuel reduction logging actually tended to have the higher levels of high severity fire. And interestingly, forests that had no management or minimal management tended to have lower levels of high severity fire. Next slide. Next slide, please. And this is an example of a dense, mature old forest in the creek fire that had no management and burned at very low severity. This is very, very common. The creek fire was mostly low and moderate severity. It had a significant portion of high severity, but about 16%, according to the most recent and accurate fire severity assessment, which is the MTBS 1 year post-fire. Certainly there's mature forests that burned at high severity too, but the majority burned very similar to this or at more moderate severity where there's some mature trees were killed. Next slide. This is another example of a dense mature forest in the creek fire that burned at low severity. You can see way off in the distance in the background that this all the way over the ridge line, this is what you saw. You can go into the creek fire and see vast, vast areas of dense mature forest with no logging history and no recent fire history in recent decades, and they burn mostly at low and moderate severity. And the reason for that is because, number one, that's what the weather dictated in that moment, relatively less, lower fire weather, but also because the denser mature forests have a sort of buffering effect against extreme winds driven by climate change, extreme weather driven by climate change. Next slide. And this is an example of an open forest, a more open forest where commercial thinning had occurred that burned at very, very high severity. This entire area and over that ridge in the background and down the other slope, very, very large area that had been commercially thinned and burned mostly at high severity. Certainly, there were also commercially thinned areas that burned at low and moderate severity, just like there were unthinned forests that burned at high severity. But the point is that on balance, these thin forests tended to burn at higher severity than the unmanaged forests. Next slide. And this one was even more of an open forest, more intensively logged. And the idea, was, supposedly to create wide spacing between trees and reduce what they call ladder fuels. Problem is, forest fires are not nearly that simple. And when you remove all those trees, it allows the fire to burn more rapidly and more intensely, oftentimes, in those forest ecosystems. Fires come from the ground up more than anything. Next slide. And this is a landscape shot of the Southern California Edison forest lands that for several weeks after the Creek Fire burned there was a very misleading false narrative out there that the Edison lands had been commercially thinned for about 40 years and the fire burned mostly at low severity in these Edison lands. Nothing could be further from the truth. That's actually the area that burned the most severely, and it was predominantly higher severity fire that occurred on these Edison lands. And you can see in the middle there, they were already post-fire logging these high severity fire patches in areas that burned hot after they had been thinned for years. Next slide. And this is a large high severity fire patch in an area that had been heavily post-fire logged decades earlier in an earlier fire. And the post-fire logging was done under the guise of fuel reduction. And again, what you can see here is that the areas that were heavily managed under this notion of fuel reduction often burned the most severely. And this is not to say that high severity fire is bad. High severity fire creates all kinds of great habitat benefits for many different wildlife species. It's incredibly good habitat. You still have the carbon stored in the dead trees. It's great for many things. The point is that when you're doing these logging operations, you're degrading wildlife habitat, you're removing a lot of carbon from the forest, putting most of that into the atmosphere, and it's not accomplishing its stated goal of supposedly stopping fires from reaching towns or effectively reducing fire severity. That is not what we're finding. Next slide. And I found similar things, and I studied the Antelope Fire of 2021, published this paper earlier this year. I looked at cumulative severity. In other words, the total tree mortality from thinning itself, and then also from the subsequent wildfire, because there's a huge bias in the last 20 years of research coming from the Forest Service on the effects of thinning because they don't take into account the tree mortality from logging itself, including from commercial thinning. And that's a huge source of bias. So I tried to correct for that. I took that into account. And what I found is that cumulative severity is significantly higher in the thinned forests than it is in the unthinned forests. 59% overall tree mortality on average in the thin forest versus 39% cumulative severity in the unthinned forests. Next slide. And Bryant Baker and I found the same thing in the Caldor fire in a subsequent paper. Cumulative severity significantly higher in the commercial thinning units relative to the unthinned forests. Next slide. And this is really important from a community safety, a public safety standpoint, because the tragedy is that the Forest Service and the logging industry and a lot of elected officials have been telling these communities, these vulnerable communities, that these logging projects out there in the wildlands, out there over the ridge somewhere, that are being done under the guise of fuel reduction or commercial thinning, that's somehow going to save them from fire. It's going to stop the fire from reaching the town. And this is a quote from a report from a recent logging project that was done near the community of Grizzly Flats, but it was out in the wildlands mostly. And they said, well, these commercial thinning units out in the wildlands will slow or stop the wildfire from reaching the town, even under high fire weather. Next slide. And this is actually an image from the report, and it's a little bit difficult to see, but basically what this is telling, what this is communicating is that when the fire, those kind of curvy little lines, when the fire reaches those thinning units, which are the purple and green kind of modeled areas, it'll just stop and it won't reach the town. And that's what people were told. Next slide. But here's what actually happened. Grizzly Flats is on the western central portion of this image here. And the black crosshatched areas are the commercial thinning units. And what you can see is the fire, which started at the southwestern portion there, it went north and northeast, and it burned right through all these commercial thinning units, almost exclusively at high severity. And it destroyed most of the town of Grizzly Flats. That was preventable if we had focused where we should have focused, and this is what we asked them to do. Instead of backcountry logging, we asked them to do defensible space pruning within 100 feet of homes and communicate to the homeowners how to do the home hardening to make their homes more fire safe. We know that's highly effective from the science, but backcountry logging is not. Next slide. And this slide got turned sideways somehow, but bottom line is on the other side of the Caldor fire, these narrow zones right next to homes, within about 200 feet of homes, where there was not even, it wasn't logging, it was basically pruning, essentially defensible space. That was effective in combination with fire suppression, water drops right next to the community. That actually did save homes, and people had done their defensible space in addition. But that wasn't about backcountry logging. It was about defensible space pruning within 100 or 200 feet of homes. Next slide. And this is a map showing the campfire of 2018. Between the point of origin on the right side of the image and the town of Paradise on the left is an area several thousand acres in size that was one of the most heavily logged areas in the entire northern Sierra Nevada prior to the campfire. Vast areas of post-fire logging from earlier fires, commercial thinning, and other logging, all done under the guise of fuel reduction and restoration. And the community was told that it would save them from fire. In reality, that's what the campfire burned through the fastest and most intensely, by far, in those first 6 hours. 86 people lost their lives and over 14,000 homes were burned as a result. This approach is not working. This approach is a proven, demonstrated failure, and we need to change direction, because if we keep the carbon in our forests, as Dr. Law mentioned, and we increase the protection for forests, we will have enormous benefits in terms of climate change mitigation, in terms of biodiversity protection, including those post-fire areas, which are very important habitat, as Dr. Bond will talk about. But also we can redirect logging subsidies into a jobs program to create fire-safe communities through home hardening and defensible space, the only things that actually work. Next slide. And there was a trio of articles recently, last year, by a number of scientists who were funded by the Forest Service, Pritchard et al., Hagman et al., and Hesberg et al., in the journal Ecological Applications. And they falsely claimed that the science is settled and that somehow the commercial thinning is should not be questioned as a fire management approach. But the interesting thing is the primary study among those three that really talked about thinning and fire and delved into it, next slide, repeatedly admitted over and over and over again that the opposite conclusion tends to very frequently be true, that thinning can cause higher surface fuel loads, quote, end quote. Thinning, quote, can contribute to high intensity surface fires and elevated levels of associated tree mortality, end quote. And, quote, elevated fire intensities, end quote. Thinning, quote, can lead to increased surface wind speed and fuel heating, which allows for increased rates of fire spread in thin forests, end quote. And so on. And so there's a whole series of these quotes that contradict completely the notion that they were trying to present, that somehow no one should question thinning as a fire management approach. there is a large and growing body of evidence telling us that commercial thinning and other logging out in the forest is not a wildfire management solution. Next slide. And in fact, the Pritchard et al. Study cited a number of previous articles for the proposition that there's a body that these articles say that thinning is effective. And we looked at those studies in Della Sala et al. 2022, and we included an analysis of that. And it turns out that there's a whole series of earlier Forest Service studies that claim thinning is effective, but the results of those studies do not support those conclusions and often contradict them. And so there's a disconnect even within some of these studies that are often cited to promote thinning as a fire strategy. Next slide. And the last thing I'll talk about very briefly is this notion that forests with more dead trees will burn more intensely. And that's another notion that has been very strongly debunked and discredited by most of the research out there. The largest and most comprehensive studies by far are finding that forests with more dead trees either burn at about the same levels of fire severity or intensity, or as this study found, they actually have lower fire intensity oftentimes. Next slide. And I looked at that in my Creek Fire paper, and I actually found no relationship between the density of snags, in other words, dead trees, and the percent of high severity fire in unmanaged forests. Next slide. And so why is that? Well, I think a lot of it has to do with the fact that dead trees really, don't have much to carry flames once the dead needles and small twigs fall and decay into soil. And when those dead trees fall, they become like giant sponges. They soak up and retain huge amounts of soil moisture, huge amounts of moisture, and they can hold 25 times more water per unit of cubic area than the surrounding soil, even in a drought year. So it's much more complex than people often think. The dead trees and the down logs are not a significant driver of fire severity, and these logging policies that are focused on removing them are counterproductive, and they're making, again, climate change worse. Next slide. All right, so that's last one, and I will turn it over back to Heather. Thank you.
Thank you so much, Dr. Hanson. Really appreciate the information. We're now going to hear from Dr. Monica Bond. Dr. Bond is a wildlife biologist and principal scientist at the Wild Nature Institute. And she's going to talk to you about post-fire habitat and biodiversity.
Okay, great. So Heather, do you want to stop sharing? Okay, perfect, great. Hi, everybody. Thank you. Let me share my screen. And how is that?
Looks great.
Great. Okay, good. So Dr. Law spoke about the importance of forests in capturing and storing carbon, and also how little of the carbon emissions actually come from forest fire. And Dr. Hanson then spoke about the sort of inadequacy of fuels treatments in affecting fire behavior when fires are climate driven, big wind driven types of fires. And so I'll be talking a bit about what happens ecologically when a fire does burn, when a severe forest fire does burn. So I'll discuss the science about the rich biodiversity after severe fire, and I'll have an overarching message that the huge number of native plants and animals that thrive after severe fire shows that this is a natural habitat creating process in our North American forests. So as a bit of background on myself, I've been studying interactions between forest fire and spotted owls over the past 20 years or so. And I've also done field research on black-backed woodpeckers, which are strongly associated with severely burned forests. And I've spent quite a bit of time in burned forests, not only with my research, but also because these habitats are just amazing places to see wildlife. And I'm going to focus on Western forests in this talk, but this applies to Eastern forests as well. I don't know how much of the audience are folks from the East, but Eastern forests also, when it burns severely, there's really wonderful ecological things going on. So let's begin with What happens when a forest burns? Wood-boring beetles are the first to show up in a severely burned forest. They come before the fire is even out, and they're so well adapted to fire, they actually have special organs that can sense smoke or heat from miles away, and then they flock from the surrounding areas to lay their eggs into freshly dead trees. And their millions of larvae then munch their way under the bark. After the high severity fires burned out and the first rains have fallen, you'll have standing dead trees, fallen logs, resprouting shrubs and tree seedlings, and lots of wildflowers. All of these elements provide critical food and shelter for a remarkable diversity of animals. The beetle larvae are valuable food for the next fire-loving animals to come along, the woodpeckers. And I'm not sure if you can see the bill. You have woodpeckers love severely burned forests, especially the blackback woodpecker. They eat the huge fat beetle larvae, and this woodpecker bill actually has a beetle larvae in it. And those larvae remain inside the dead trees for years, providing food for all of that time. And the woodpeckers come for the big abundance of food, and then they make nesting holes in the dead trees. They make a lot of these nesting holes, and other birds will be able to nest in them too, birds that can't make their own holes. And we're talking about bluebirds, house wrens, nuthatches, kestrels. There are also a lot of native wildflowers that are only seen after a high severity fire. How about mushrooms? The best place to find fire morels is the most severely burned forest. Regrowing shrubs and flowers support a superabundance of insects, which bring in birds like olive-sided flycatchers and lots of bats. The fresh new shrubs also feed deer and elk. And seed sources on the ground are exposed, so you get a giant boom of seed-eating rodents like deer mice or gophers that eat the herbs that are growing in the nutritious soil. And this small mammal boom brings in predators like, for example, spotted owls. Spotted owls often prefer to hunt in the severely burned forests, and they eat lots of gophers there. Spotted owls like forests with a lot of medium and large trees, whether those trees are alive or have been burned in a fire. So the natural mix of different burn severities that we see in forests with plenty of large trees provides quality habitat for spotted owls. The burned forests are like the kitchen where they can forage for their food, and the unburned or lightly burned forests are the bedroom and the nursery where they can sleep and raise their young. Some species like spotted owls might be considered resilient to severe fire, and they can take advantage of burned forest habitat when it's created, but they don't need fire to survive. There are species of native plants and animals that don't just tolerate the severe fire, but they require it, like the wood-boring beetles, wildflowers, woodpeckers, and fire morels. There are many other species that are simply more abundant in severely burned stands than any other habitat type. Severely burned forests are incredibly biodiverse, and they rival old-growth forests in terms of the number of species that thrive within them. Decades of research throughout the Rocky Mountains, led by ornithologist Richard Hutto, has shown that many birds are far more abundant in post-fire forests than any other habitat, especially cavity nesters like woodpeckers and bluebirds. So here, this is the blackback woodpecker, and these are different habitat types. This is post-fire, so you can see how it's almost restricted to these post-fire habitats. And then you have the American three-toed woodpecker, Lewis's woodpecker, and western bluebirds that are far more abundant in burned conifer forests than anywhere else. Different plants and animals become more abundant at different times after fire. And what this means is that if you visit a severely burned area immediately after the fire, you won't be getting the full story, because some species begin to increase only after a few years. The forest is used at every serial stage, between 100% mortality, when it's nothing but black sticks, to a year after the fire, all the way to 300-year-old old growth. The dead standing burned trees are critical habitat, and after a time, some of them will fall, and the burned area might look a bit more like a shrub field for a while. But within the shrub field, tree seedlings are taking root. And it might take an infuriatingly long time for us humans, because we tend to have short-term vision and live in the moment. But the vegetation will grow back according to current climate conditions. Different species are also relatively more abundant in different burn severities. So not only is time since fire important, but it's also important to look at species response to different severities. And some do like it hot. The positive benefits of severe fire are seen for many different kinds of organisms. Researchers in Idaho recorded more bat echolocation calls in the high severity fire areas, and they also documented more emerging aquatic insects and spiders, which the bats were feeding on. And similar positive effects of severe fire have been found for bats in the Sierra Nevada. In Montana, researchers showed that severely burned forests were population sources for deer mice into the surrounding unburned landscape. And the authors, Zwalloch and Forsman, stated, "There's unique ecological value in severely burned forests, which needs to be weighed against the prevailing view that such natural disturbance events are catastrophic." Wan et al. Showed that the largest severely burned patches had the best aspen regeneration in forests all across Utah. And this was because ungulates like elk are drawn to the burned areas so they can browse on these new fresh aspen leaves. So the bigger fires can actually saturate the browse capacity of elk. So preeminent fire ecologist and one of my personal heroes, Richard Hutto, put it best. The biological uniqueness associated with severe fires could emerge only from a long evolutionary history between a severe fire environment and the organisms that had become relatively restricted in distribution to such fires. So the implication of this, it's not that most organisms can survive severe fires. It's that many require severely burned forest conditions to survive. A lot of people are beginning to understand and embrace the ecological importance of fire in our forests, but there seems to be acceptance mainly for just low severity controlled fire. Yet the fundamental message from the scientific research is that severe fire creates essential habitat for the bats and the birds and the beetles and the mice and the flowers and the mushrooms. Fire that makes the forest look like this picture. Even old forest species like spotted owls can exploit conditions created by severe fires. So there's no good fire and bad fire, which is a message we see a lot from the Forest Service and the National Park Service, and even from some environmental groups. The strong association between high severity fire and so many native organisms demonstrates that hot fires have burned in our forests for thousands and thousands of years and are as vital to the forest ecosystem as rain or snow. These fire-adapted species are telling us an important story about their co-evolution with severe fire over millennia. We need to listen to them. Unfortunately, vilification of fire and burned forests leads to support for cutting down the snag forest and replanting a plantation. And this happens regularly on our public lands. Even though trees and shrubs grow back better without human intervention, and according to their ability to persist on that site given current climate conditions. To demonstrate how pervasive salvage logging is, Dr. Hanson and I analyzed every published study that showed a negative effect of high severity fire on spotted owls. What we found? Every single study that showed negative effects of severe fire also had post-fire logging somewhere around the owl's home. A recent published global meta-analysis showed salvage logging harms nearly every form of life, from birds to mosses, lichens, arthropods, beetles, and fungi, all the little things that make the world work. So the take-home message from the science is that there are winners and losers from both severe fire and from salvage logging. But overall, there are many more winners from severe fire and many more losers from salvage logging. Severe fire is natural and necessary, and salvage logging is unnatural and destructive. So I only had time here to touch upon just a few of the studies, but there's a vast literature out there about biodiversity and severe fire, and I'm happy to share all that I've got from, if anybody, if you want to contact me. And I really like sharing this scientific evidence about the ecological importance of severe fires. It's a story about native fire-adapted plants and animals that thrive after the hottest fires. And it's a positive and uplifting story for people like us who love forests. Because when severe fire burns in the forest, we don't have to despair. 100 years ago, foresters once thought that old growth forests were decadent. They needed to be cleared out and replanted with vigorous young trees. And we later realized that folly, and we established protections for old growth. Let's not make that same mistake here. Let's recognize and embrace severe fire as natural and protect snag forests as vital habitat. And given the theme of this coalition, the Forest Carbon Coalition, it's also fortuitous that leaving the forest alone to do its natural thing is the best for carbon storage. Thank you.
Thank you so much, Dr. Bond. All right, we are going to jump into questions. We have got a lot, so we'll try and get through as many as we can. And as I said in the beginning, any that we don't get to, I will try and get answers for you and send out that information when the recording goes out. All right, so panelists, these questions, some of them, it will be obvious whose presentation it's directed towards, but if not, please jump in. And if you'd like to answer the question, and some of them, maybe you each have something you'd like to contribute. So the first one, can you talk about the benefits and liabilities of carbon offsets? We need a deeper analysis. Dr. Law, I think maybe if you want to start off with that one, and you're currently on mute. There you go.
Yeah, I couldn't get that other window out of the way. So we did okay. I think that when you have something that it's a compliance-oriented carbon offsets program, that you can succeed by capping the amount that corporations can write off, because they're basically saying, I'm giving you money to protect those forests, and therefore I'm reducing my emissions by doing that. And there's, I think what one of the benefits is that can work if it's monitored carefully, and if projects are not it's too weak or in the how they decide what projects can be funded and what projects qualify. And that's I think it's the American Carbon Registry is the problem area. And that we shouldn't have that. That should be more of a federal level decision-making process, so that it's not somebody that's just saying, yeah, you wouldn't believe the projects they allow to go through. So the downside is a lot of bad projects go through. Somebody's claiming it and they're advertising that they're doing all these great things for environment, and it's having no effect on the greenhouse gas. It's not really offsetting greenhouse gas emissions. They're not really reducing it. With the compliance system might work fairly well. Like the carbon markets is where it's the wild, wild west. And there are so many involved in it too, NGOs and major corporations, timber industry involved in that. And when you find out what some of the projects are, or they were already, there's a problem with additionality. They'll say, well, we're protecting it in perpetuity, but it was already protected. It was a reserve. There are things like that have gone through. It just needs to be policed and have independence making the decisions on what gets funded or what can be called an offset. The amount of carbon that they're really protecting, we don't really know, because it's not transparent. There's nobody monitoring it. There should be a monitoring program. That's my last statement. It was that you need to have the monitoring of the carbon by those who are experts in carbon monitoring and carbon accounting. And it should be an independent body. So I guess there's there's like with the California system, they allow the corporations to offset at most 8%, but you could lower that number. States could experiment with that by lowering that number. Another thing is with the additionality, I realize there are some people that, like in the Coast Range here, who own the land and they want to protect it, but they're barely making ends meet by, and they have to pay taxes on it. So some sort of assistance would help. I think there's a better arrangements that can be made rather than using the offsets market. And then they might be state run or federally run. But so far, we're not impressed with it.
Yeah, I'll add to that briefly. Just one alternative to kind of the offsets notion is, first of all, just acquisition of forest land, private forest land from willing sellers. And we need to allocate a lot more money from state and federal coffers to do that, so that we can protect a lot more forest and basically take it out of the timber production base. And the other one, of course, is conservation easements. So if someone doesn't want to sell their land, but they're perfectly willing to set it aside, permanently as protected forest, conservation easements can be a really good way to go too. And that costs money, but again, we need to pony up the money to do this.
Thank you. Next question. How does changing management on GAP 3 lands result in status change to GAP 2?
I think it wouldn't happen overnight. It's not like a light switch would be flipped, but there may be some management activities that are going on that are they're doing too much, or taking wood out or whatever. But if they stopped doing that, then and let it grow, it might be able to get into that kind of status. But it would have to be monitored again to make sure that it's doing what you would expect it to do.
Thank you. Next question. Should we be planting trees in the grass and hay cultivation areas of Oregon, Washington, and California?
So there's more detail to that. There's grass and hay. Okay, so and that follows what we were going for: non-food grass, non-food crops, and non-food grass crops. And that's because that right now it's just been off limits. It's always said, if it's a food crop, no, you can't do that. Well, I think there needs to be some bending in that, because if it was forest before 50 years ago, 30 to 50 years ago or more, it should be able to go back to forest. But what you have to be able to determine is the soil destroyed so much that it can't support forest now? So what we did is we looked at the soil water holding capacity for forests that belong there, and determined what areas could actually support forests now after they've been in agriculture for 50 years. So it's possible that afforestation could happen. What I worry about now is the shifts that happen in agriculture. There are going to be a lot of different things that, like all the grass crops, we might discover that we have some other different things that we need to plant with climate change, because the current plants aren't going to survive it very well. And we might need to allow crops to shift to that. But it could also be some of these areas, these non-food crop areas, that could be shifted to food. So food always seems to win on this, but we might be able to. There's a lot of work being done on smart agriculture with climate change. I think it should be considered. There are areas that are just not been doing very well as they are under grass or under hay, and they're irrigating too much. We also showed in another study just how much water would be saved if we grew forests in the valley instead of the grass crops. It's an amazing amount of water because it's irrigated so much. Half the valley is irrigated, and with these booms, aerial booms. So there's a lot of wasted water, and water is a critical factor in decision making.
Thank you. If dense forests do burn more intensely, what about commercial tree plantations? Those are often said to burn more intensely, and at least in Oregon's Coast Range, they are very dense. So there's so many trees you can't see between them.
Yeah, the denser, more carbon-rich forests tend to burn at lower intensity, not higher intensity. So the forests with the more mature forests that are more carbon-rich and typically have higher canopy cover, those are the ones with that cool, moist microclimate because of that density that tend to burn at equal or lower severities when fires occur. Plantations are a little different. You know, it's interesting. There's a lot of research on plantations. They do tend to burn more severely when fires occur. A lot of studies find that. I will say that a lot of people assume that if you have a tree plantation, it's always going to burn at high severity, or almost always. And they still burn mostly at low and moderate severity in most ecosystems in most of the larger fires. There certainly are exceptions to that. But on average, they have higher levels of high severity. I would say really for me, I think you're not going to stop that by thinning those plantations. I think you need to keep the carbon in those as well and let them basically mature into more carbon-rich, more ecologically important forests over time. So really, that's what I'd really like to see for the plantations, especially those on federal lands.
Can I add something to that? So the traits, there's a really neat study that came out that looked at all the plant traits for different species that affect their ability to withstand fires or be resistant to fires. And it's being tall and having thick bark are the major ones. Young trees in plantations have very thin bark and they're short. The canopies are closer to the ground, so flames can get up there easier. So that's just part of the dynamics anyway.
Thank you. This next one is for all three of you. Can you speak to how the carbon biodiversity work you're doing in forests relates to shrublands like chaparral, etc., that are also increasingly targeted for thinning or removal projects like in the Los Padres?
So our studies include woodlands, and woodlands have 10% trees. That's kind of the rule that the Forest Service uses. At least 10% of it, the land area is trees. And that includes juniper. So when we do the analysis, that's in there. But that this kind of thing could be, this kind of analysis when we're looking at protecting 30-30 and 50-50, it's not just about forest ecosystems. It's some of the other valued ecosystems like the prairie lands that could be protected for the wildlife. It's not so much carbon. They have more of it below ground in the soils than they do above ground and in the roots. But a similar kind of study can be done for these other important ecosystems, shrublands and grasslands.
Yeah, and I'll just echo that shrublands are incredibly important habitat for many species. So yeah, I think they're really undervalued.
Mm-hmm.
Yep, I agree on that. And there's certainly considerable carbon that's stored in mature chaparral. And when those mature chaparral areas are removed by various types of mechanical operations that are typically done under this misleading rubric of fuel reduction, what typically happens, like mastication of chaparral and things like that, is they get replaced by invasive grasses. And those invasive grasses are incredibly combustible. They're far more ignitable than chaparral, and they spread fire much faster. And they store a lot less carbon.
Thank you. We've had a couple of participants ask something similar to this next one. So they're trying to reconcile your messages in each of your presentations. And it seems like logging is much more harmful than fire is. And severe fire is not great for human communities. But are you saying, is it more important for plants and animals?
Go ahead,
Yes.
Jack.
Yeah,
Monica, it seems like a Monica question.
Well, I
Or
mean,
Monica.
that's absolutely right. It's not good when a fire is burning your home down, but when a fire is burning in the forest, it's there's going to be lots of plants and animals that are going to be very happy there. So absolutely right. Yeah, and that's Chad mentioned, focus being on home hardening and 100 feet out from the homes. If we focus that on those areas, then that's really where we should be focusing doing the work. Dick Hutto has said many times that the severely burned forest should be at the bottom of the priority list for logging. It's just that important of habitat for species all around the West. It's really critical. And I urge everybody to go out into a burned forest another year. I go to the Rim Fire every single year and camp out there. It was a huge fire that burned in California and the Sierra Nevada. Did a little bit of owl research there. I know Dr. Hanson worked there. I go every year because it's just spectacular what's there. And I just, you move from the sort of unburned, lightly burned area, you start to get into the areas that had burned severely. And it's just like the rich, booming life everywhere, birds. It's just, there could be ecotourism money to be made in burned forests. They're that ecologically valuable.
Yeah, I would agree with that. I mean, the snag forest habitats created by high intensity fire patches that are part of this mosaic of low and moderate severity fire effects, which are important for lots of other species. But I've been researching these snag forest patches as a field ecologist for over 2 decades, and they're ecological treasures. I mean, they're just extraordinary. If they're not subjected to damaging post-fire logging, and if natural succession goes on, every single year you're going to see more wildlife, a greater abundance and diversity of wildlife, and it's just extraordinary. So I don't see fires, including the big ones, as destructive to forest ecosystems. I see them as rejuvenating forces. And this is why I draw that dividing line between what happens with communities, what happens out in the ecosystems. And we have to recognize that, where we need to put our funding, our resources, is on protecting communities from fire instead of removing a bunch of carbon from the forest and deceptively calling it restoration or forest health or fuel reduction.
Thank you. What are the significant, and this is relating to fire severity, differences, so significant differences between commercial and non-commercial thinning?
Well, just briefly, commercial thinning is typically what happens when you hear the term thinning. 97, 98% of the time, it's commercial thinning. And these are logging projects. These are just commercial logging projects. The typical thinning project is a commercial thinning project. It's a timber sale, and it typically kills upwards of 60 or 70%, oftentimes upwards of 80% of the trees in a given stand, including many of the mature and old growth trees. Now, it doesn't remove all the trees, and so oftentimes the majority of the biggest trees remain, but large portions of carbon are removed from the forest. And there's a huge impact on the carbon storage and on wildlife habitat and on the microclimate. A non-commercial thin is basically just seedlings and saplings being removed, trees typically less than 6 or 7 inches in diameter. People also call that a pre-commercial thin sometimes. And so you're really not reducing the canopy cover. You're not really changing the microclimate. Now, I would say that you're going to get a very different effect there across the board from a commercial thin. But from my standpoint, really, the priority needs to be fire and not thinning, even if it's non-commercial, except when you're talking about areas right next to homes where that's essential.
Thank you. Are ubiquitous non-native plants and pathogens impacting quality of regrowth after high-intensity fires? Dr. Bond, maybe you can start us off on that one.
I think that a lot of the problem with non-native species incursion into severely burned forest comes from when there's post-fire logging. Again, another reason why not to do it.
Yep. Yeah, I'll briefly add to that, and Dr. Law, you may have no thoughts on this as well. But yeah, I agree. I mean, the invasive grasses are very, very frequently basically brought in by logging machinery. That's the vector for the introduction and spread of those invasive grasses. It's particularly true in post-fire logging. And so, oftentimes these invasive grasses are already there from like livestock grazing from years before, or much older logging, but typically at very low levels and sometimes not at all. But after post-fire logging, it's just pervasive, and that really can have a major impact on the regeneration as well as the soil damage from the logging.
And if I can reiterate again about the shrublands and some efforts to do a lot of prescribed burning in shrublands to try to clear out. It's like a fuels treatment in the shrublands of Southern California, but as Chad mentioned, you have invasive grasses that do come after that. So too much fire in Southern California from management or too many ignitions that is a problem as well, and I think that needs to be dealt with. Do you want to talk more about that, Chad?
Yeah, I mean, it's just it goes back to that question about fire and its natural role in the ecosystems. In forests, we have a deficit of fire still in most regions of the country, nearly all of them. In fact, of this country, we have a deficit of one level or another. We're getting closer to natural levels as fires have been increasing, and part of that's certainly climate driven. Driven by climate change, but we still have less, right? So a lot of people don't understand. They think we have too much fire simply because we have more now than we did 20 years ago. But we actually have quite a bit less in most forests than we had historically, naturally, before fire suppression. That's not true in every ecosystem type. In Southern California, chaparral, for example, we have too much fire, too frequent because of human ignitions mostly, and climate change is a factor there too. But mostly it's because these chaparral systems are right next to huge population centers, and they're right next to people doing dumb things in the middle of fire season that cause ignitions. And so it's a place where we need less fire. And so you don't want too much, you don't want too little. I guess that's the lesson.
Thank you. This is a question specifically about the state of New Jersey, although what they're asking can apply to forests across the country. So in New Jersey, there's a big push to log forests for fire reduction and for quote unquote ecological health. Can you please explain why the Young Forest Initiative is not a strategy for climate mitigation? There's a lot of greenwashing saying younger forests sequester carbon at a faster rate versus a maturing forest, and please address the reduction of fuel load myth.
Might have missed what I said somewhere in my talk. Is that that's the mantra that has been put out there, the misinformation, and it has been continually put out there by the timber industry. It's not true. Young forests are not a good way to try and mitigate climate change. What we can do, now we did do a reforestation analysis, but that's just analyzing where trees had already been cut. And like I said, young forests are still a source to the atmosphere for at least 10 to 20 years, a net source. So that first 10 to 20 years and then you think we have to make a lot of progress in increasing carbon uptake and the stores within the next 20, 30 years. So in other words, young forests, when you come in and you do any planting of young forests, they're not going to be of value to us until they're up around 30, 40, 50 years old. They'll start taking up enough carbon to make a blip, to make a notice. So yeah, it's been something that has unfortunately been out there, and it's and everybody's being told that. I know in the Northeast, they're still selling it on that. It's too bad. One of the things that I did hear about is one of the NGOs is for one species, and this is a tough decision, but one species, they're cutting mature and old forests. Well, again, we need that carbon that's stored there to stay there, because once it gets in the product pool, it's back in the atmosphere very quickly. And so they want to be able to do this for one species, and they went from something like 5-acre things to 30-acre parcels. And now they're talking about logging a lot more. There's a lot of pressure on the Northeast to do logging. There's a lot of pressure on the Forest Service to do more logging. It's everywhere. And in the US, there's increasing pressure to do more logging. and it's not justified in terms of carbon.
Yeah, and I would just add to that, and this is similar to what Dr. Law mentioned earlier about young forests with smaller trees. They have thinner bark, they're closer to the ground, they're much more fire susceptible. And if you're cutting a bunch of mature or old forest and replacing it with a tree plantation, that is not going to increase your fire resistance in that ecosystem. It will do the opposite.
Thank you. We have time to go over one more question, and there are quite a few additional questions that have come in. So participants, I'll do my best to get answers to all of these questions to send out with the presentation later on. But to wrap up, last question, while salvage logging thinning is detrimental, isn't it wise to remove small bushes and fuel around the trees?
I mean, I would say if you're talking about, again, the difference between homes and community safety versus the ecosystems, if you're talking about an area that's within that defensible space zone, within 100 feet of homes, absolutely, you want to do that, especially within that first 30 or 40 feet from the house. That's just about public safety. But out in the ecosystems, I really encourage people to think about forests and fire differently. It's not about stopping or preventing high intensity fire patches. It's about honoring high intensity fire patches as part of that mix. Even the largest fires are mostly low and moderate severity. High severity fire is a component. It's an important component. But a lot of people have this idea that if you have a really big fire, it's going to be mostly high severity. That's not true. It might only be 15 or 20 or 25% oftentimes. And that's oftentimes where your highest level of biodiversity is. That's where some of your rarest species are. And so I think, we need to just shift our thinking in terms of how we view forests and fire. Fire is a regenerative, rejuvenating force. It's a positive force in forests that typically have less fire than they need. I mean, less fire, they have less fire now than what they need ecologically.
Yep, and all those trees and little trees, shrubs, that's habitat, those homes for the plants and animals in the forest.
Thank you. Well, I do want to extend another big thank you to our panelists, Dr. Bev Law, Dr. Chad Hanson, Dr. Monica Bond. Thank you so much for being here and for sharing your knowledge with us. One quick plug for the Forest Carbon Coalition. Thank you to all the members who participated today. If you are interested in becoming a member of the coalition, you can drop your organization name, or if you're an individual, drop that in the Q&A. You can also email me at heather@forestcarboncoalition.org or go to our website. And we'd love to add more members. We have a lot of members on the East Coast, West Coast. We would love more, but if you are from anywhere in the center of the United States, we'd love more representation to represent other forest ecosystems. But thank you again for being here, and the recording will go out to everyone along with some additional questions and answers.
Thank you.
Great.
Thanks, everyone.
Thank you.